We're gonna install one more post.
Once upon a time, we got an idea to install a gray water system so water from a kitchen sink could go to plants instead of to a septic tank. Except those plants will be dormant in winter, so any funky sink stuff would just build up and be gross. How about if we made a small greenhouse? Greenhouses are famous for needing more heat than homes. All that glass is a very poor insulator. Plus, they can get too hot on a sunny day and kill everything in the greenhouse. We have a lot of projects here doing amazing things to solve heating problems. So can we invent a greenhouse that never gets too cold or too hot? Maybe we can use some elements of Mike Ayler's greenhouse design and some elements of our Wofati design, and maybe a few other ideas. Our design starts with the general shape of Mike Ayler's design from the Earth-Sheltered Solar Greenhouse book. He grew tomatoes in December off-grid with no heat of any kind in northern Idaho. The genius of his design includes 3 improvements over a traditional greenhouse. Improvement number 1, reduce the size of the airspace with a trench. Improvement number 2, an earth berm on the north side, thus some added insulation and less glass. Improvement number 3, most importantly, the 5-foot deep trench under the walkway. I think that the trench adds a big dose of superpowers that most people overlook. If the deep ground temperature is a constant 50 degrees, then whenever the temperature in the greenhouse drops below 50, the 50-degree air from the trench will rise up and the colder air will sink down. Before he died, I talked to Mike about another possible improvement. Improvement number 4. What if a copper pipe was blackened, shaped to follow the glass vertically, and drop down near the bottom of the trench? When the sun hits the greenhouse, the top of the pipe would heat up and act like a straw to pull cold air from the bottom of the trench. Eventually, the hot air at the top of the greenhouse would be pulled into the trench and warm it. I called it a destratification pipe. Mike agreed that this would probably help a lot. Improvement number 5. A common farmer trick is to put 20 feet of well casing into the ground, then put a watering trough on top of that. When the outdoor temperature is negative 25 degrees, the water doesn't freeze. When the water gets cold, it cools the air at the top of the hole. So the 50-degree air from underground rises to the top and the colder air right below the trough sinks. There's so much air exchange that the water remains warm enough to not freeze. With this trick, plus the previous improvements, maybe we can circulate enough heated air from the greenhouse through the pipe to get the temperature at the bottom of the hole closer to 70 degrees instead of 50. Improvement number 6. Our Wofati house design attempts to use heat from the summer to heat a home through winter. We do this by berming dry earth against and on top of the structure and keep it dry with a membrane we call the umbrella. We're still experimenting with these structures, but so far they've had no freeze, even in our Montana winters. So let's add dry dirt to the roof, the west side, the east side, and the north side, and an umbrella to keep that thermal mass dry. Improvement number 7. Our original mission was to design a year-round gray water system for a cold climate. In this case, the problem is the solution. Gray water tends to be warm. If part of the greenhouse is dedicated to accepting gray water, then there's a constant stream of warmth pouring into the greenhouse.
I'm Josiah, and I'm going to build this greenhouse. Our project has been successfully funded on Kickstarter, which is super cool. Thank you so much. It also means that we now have to build it. This design has so many experimental innovations involved that before we can even think about starting to build, we need to figure out some details. So here we are. Welcome to part 1. I began by making scale drawings of the framing and passing them off to our engineer friend Kyle to make a virtual model.
Hi, my name's Kyle. I did the 3D modeling and the drafting and helped with the design on the first Wofati greenhouse.
Building the greenhouse on paper and then in the computer model helped us solve a lot of problems and get a lot of details and dimensions down. It also brought up a whole bunch of questions. To answer these questions, we decided to bring in some help. We hosted 4 virtual design meetings with some of our Kickstarter backers, and these conversations clarified a lot. You can watch them in entirety on Permies.com, but here's a highlight reel that has a tally of all the design decisions and details that came out of these meetings. We'll start with Paul's original 7 design features and add to them as we dig deeper.
Oh, I think this is actually a good place to start our meeting. To dive right in, maybe we can talk about where we're at and then open it up for other people to ask questions or give ideas.
I'm worried that if they're not covered, rainwater is just going to flow down the stairs. It's going to puddle up in front of the door.
The entry is now from the side here. This wing wall has been pulled back to allow a lowered side access, and the glass has been increased in size.
The thing is that dry soil has an R value of 0.65 per inch, which is pretty low. But when your wall is 6 feet thick, it's like, oh, it turns it to be all right. So taking some of that soil away will affect insulative ability. I could be mistaken, but polycarbonate, that sounds like plastic, doesn't it? But we're doing our very best to try and minimize the use of plastic. And so if we can use glass instead of plastic, we will.
Okay, the question, of course, is if you're trying to get solar gain, then what kind of glazing are you putting on the window? You're looking at probably a non-glazed window or a window with the glazing you've chosen to accept infrared radiation in order to be able to get passive solar gain. That being the case, you also, unless you do something, will have passive infrared loss at night, which can be a massive heat in both. There's a conductive heat loss through glass, and then there is a radiative heat loss through glass. And so I have been thinking back in my brain if there's any way that you could do a completely passive thermal curtain that came down at night, came back up during the day, because I've done that in greenhouses before, and boy, does that make a difference. I mean, it's a huge difference.
Paul's stance that he's put to me about these types of solutions is that we can't really know if they'll work until we have the greenhouse canvas to try them on.
Let's call it a non-premature optimization, in that let's not do it until we've encountered a problem. Let's see what the problem is that we need to solve first.
And I agree with Paul's impulse there. I think you start with the baseline and you figure it out, and then you can embellish from there.
I kind of want to say that, this is going to be version 0.7 of this Wofati greenhouse, and then there's going to be a lot of things learned from it. And then once we learn those things, we can build a whole nother greenhouse that is going to attempt to be the next version. So I kind of feel like we got to get 3 of these under our belt before a 4th one can be built. That's going to be called version 1.0. Today we shifted things a little bit, and we made it so that would effectively be some sort of tub, possibly an actual bathtub. That would make it so that the structure could remain dry, or drier anyway.
We're no longer going to be infiltrating water in the subsoil inside the building.
What if we put in 6 to 8 inches of gravel at the bottom of the hole, and then we put the post in, then had the excavator push down on the post until the tracks come up in the front. So it's like that post is sunk down as deep as it's going to go. Then start refilling the hole with gravel, packing it every foot or so. And so then that way, the whole post is surrounded by gravel. So if there's any moisture that's going to come off of that post in any way, then it's going to hit air and only air.
The coping joinery, at my skill level, it takes a long time. And so I've opted for just making flats and matching the flats up, which is making flats that match up is also very difficult, but I've been able to do it thus far, so.
Most of your strength of the beam is on the outer surface of it. That's why so many structural members are tubing. When you have it in bending, what you really have is compression on the top and tension on the bottom surface of that beam. So if you think of like a log, like a big collection of fibers, like a bunch of straws all together, and you try to bend that, when you cut one or two on the very surface of those straws, you're really losing a disproportionate amount of your strength.
What Paul just drew here, this little L in red, is sort of where we have met in the middle, because it requires a minimum amount of notching and matching notches, but it also conserves this strand of fiber on the very outside. So you have the notch here, and then a flat, and then you've got your post notched to receive that.
Yeah, baby. Yeah! That's what I'm talking about! Yeah!
If you have plants in there transpiring, they're going to be pumping a lot of gallons of water into this space. You know, there may be 10, 20 gallons of water a day going out as water vapor and then hitting, you know, condensing on the cool part of the structures and running down it. Okay, so the system that I described is pretty much no maintenance. A branch drain onto soil with a mulch basin is as close as you can get to no maintenance. A constructed wetland or a constructed mulch basin that has a bottom is about as high maintenance as you can get. And specifically, the maintenance is that you have to dismantle the whole ecosystem at points and rinse off all the constituent parts, the gravel, and then reassemble it again. And the reason that you have to do that is because it clogs. If you want a longer maintenance interval and you don't want black mayonnaise coming out of your system, that having a little bit of extra headroom is really going to help you with that. And you don't want black mayonnaise coming out of your system. And when it goes anaerobic, like that can be a non-linear process. And you don't want black mayonnaise.
Black mayonnaise. Black mayonnaise.
Black mayonnaise.
Now you've got a pretty substantial engineering problem. Because what you're doing is you're taking over with human effort and engineering and expense what nature's soil sponge could be doing for you at relatively low effort.
Art Ludwig made it very clear that our initial plans for the gray water system were problematic, so I came up with the most simple alternate prototype that I could think of. Inside the greenhouse, we have bathtubs filled with wood chips. The idea is that the wood chips act as a carbon sponge to absorb nutrient from the gray water. Fungi will myceliate the wood chips and further increase nutrient uptake as they decompose the lignin in the wood. The outflow is directed to a receiving landscape that has willows planted. The willows will absorb any nutrient left in the effluent. The beauty of this prototype is that there's no aquatic plants pumping humidity into the inside of the greenhouse, and that maintenance is simplified as the entirety of the wood chip basin can be refreshed and there's very few parts and no gravel media to wash. This free draining design should help keep the system aerobic, and the spent wood chips can be returned to the landscape as a nutrient-rich mulch. Sounds too good to be true? We'll find out. One of the problems that we've noticed with previous Wolfati builds is that the front corner is a little too exposed and has begun to deteriorate over time. We wanted to solve this problem in the greenhouse design, so Paul and I got out our 3D modeling kit to try to figure out how we could extend the eave to possibly protect the posts and walls a little bit more. What we decided to do is to add dry storage underneath the wing wall, which will allow us to extend those roof poles and cantilever a larger eave. To prevent the earth on top from eroding away, the wing wall roof needs to slope very gently all the way to the ground. This required it to have a very long run. In the new design, we added a 90-degree elbow in the middle, effectively breaking the wing wall into two perpendicular walls that shelter and brace each other against the weight of the earth behind them.
And so we add in 4 more posts and we do a turn back. The whole thing ends up a little bit more compact. It's taking up a lot less real estate, and most importantly, it looks boss.
You think this looks boss?
I think it's going to look really cool.
I think it'll look pretty cool too.
So what we'll end up with is that there'll be earth all the way around, and then there'll be this little kind of opening here.
Right.
With some glass in it, and then you walk in this little narrow path in the middle and you hang off to the side to go into the door on the side.
So there it is. With the new wing wall design, the plan for the framing was finished enough for us to begin to build. We know things are going to change, we're going to come up with more ideas, and we'll get more specific, especially once we have the tools and materials in hand. But I'll have to tell you about that later. Now, it's just time to begin the build. Material that's really showed up for the greenhouse. The build starts on Monday, which is just 3 days away, and starting to get real excited. Still so many things to figure out, solidify. The actual location of the greenhouse hasn't yet been finalized. We have a whole bunch of people showing up potentially next week to help out with the project, so that's going to cause all kinds of fun. Bring it on. Woo!
We have learned an enormous amount by building this structure, and if we had do-overs, there's probably 27 things we would do differently.
Right.
And then as we're standing here debating about where to put this greenhouse, it's kind of like, man, I wish we had more room here.
Right.
With putting it right here and snugging it up a little bit closer to Allerton Abbey and having them share their umbrellas a little bit, and in such a way that it comes in like this, but it's like this.
Yeah.
So that way any water that lands right at the share point still has, a downward path.
They'll share a ridge. Yeah.
I think that'll be cool.
Yeah.
As you know, so it's like, no, this is all going to be amazing. And I think in the end, we're going to feel like our design is actually really good. I feel really good about what we just talked about.
Great. Me too.
I'm excited.
Yeah. Yeah. No.
Except notice where the sun is and that those trees are in my way.
Yeah.
So I do think that it's like, you know, those trees right there, you know what they're saying to me? They're saying, I want to be a greenhouse. I think that's what I hear them saying. And it's like, boy, it sure is convenient that they're right there.
No, it's a parasitic wasp, actually. So it's your first day here.
Yep.
How are you enjoying log peeling?
It's great, man. Just being out in nature. These pines, what are these trees? Doug firs?
Doug firs, ponderosa pines.
Yeah, they just smell so good.
So good.
So good. So I'm having a blast.
Excellent.
At Wheaton Labs.
There you go. Not even
Yeah.
I'm sure this is awful technique.
Looks like a great technique.
Cool.
Look, Fred made a brush pile. He got the BB.
I don't know, it's pretty exciting, a little bit nerve-wracking. Just, we've been peeling so many logs for this. Scared to actually cut them.
Hopefully we got it all right.
Voice will echo me no frown. Ruled by the laws above.
Wow.
Anybody else? Big hole statement? Could be bigger. I mean, it's only halfway. Not even.
You serious?
Yeah. Statements? Big hole?
Statement. Well, that's a big hole. Why?
What I've been pulling out of the hole down at 25 feet deep is pretty much pure clay. It's very clean, very thick, and there's a lot of it. The scale of the earthworks is really large when you're trying to dig a hole 30 feet deep with the excavator. I think that if I was going to do this in a less disruptive way, I would probably I'd probably use an auger to drill down. We've broken through the clay layer into a fine sand, which is great for drainage at the bottom of those pipes. I'm still at 27.5 feet deep. Unfortunately, I can't dig any deeper from this position. I got to bring the tractor access road down so I can reach a little bit further and take it all the way to 30.
Uncle Mud here with Josiah at Wheaton Labs. We're standing on top of what looks like a large pile of dirt.
Now that we got these pipes in place, I can bring the level of the earth down so we can start the framing. To help settle the disturbed earth at the bottom of the cold sink, we dumped 1,500 gallons of water down the hole and let it soak for 2 weeks. This gave us some time to prep more logs and do some much-needed excavator repair.
Look at that. It's awesome.
It's go time.
Very good. We live in a wonderful age. It's a great time to be alive. Anti-gravity craft. We'll also get to the point where we won't even need the wireless transmission of energy.
Just made my mark on this big, beautiful log here. That'll be one of our tallest posts. 4 feet of it will be buried, and 15 feet of it will stick out from the bottom of the cold sink all the way up to the top of the roof, the highest point on the roof. There it is. I use a 6-inch diameter log to pre-compact the post holes before I add the large rocks and install the posts. I push down with the excavator until the tracks come up off the ground. Dropping post number 2 in its hole. Woohoo! It's a funny thing about leveling a piece of roundwood because it's tapered, and so you want to get it out of level in the same way on either side of the log. Oftentimes you're just freestyling it because there's a whole bunch of knots preventing you from getting an accurate read. Once the posts are installed, I again push down on them with the excavator to help compact the rocks underneath.
That's Marshall here. This is me, Des. And this site is the greenhouse project. Basically this horizontal thing here. And to start, we make a notch on this existing post. And then we make another notch here on this other existing post. Did this thing just turn off?
Over here we got notch A, and then over here we got notch B, all nice and chiseled out. And we are about to put brace C into those notches. Make sure you press record.
I did! I like that I had to check.
We really need to sharpen that saw. Nothing like mixing cob in the morning.
Just gently. What do you want from me? I'm spreading mud on this wall, aren't I?
Wow, that's some complicated string geometry you've got going on there.
Be talkative.
Yeah, I'm pretty bad at that. Excuse me, pardon me. So this will show us how much I have to fill up with rocks below the post. About right there. Oh, yeah, I got a good foot. Alright. In a nice even fashion. Oh, look at that. With a rock! Got a base pretty well established. And now on top of that, I'm gonna pour some gravel. Now where are we at? Perfect. Alright. So the measuring stick stick was touching gravel at the bottom of the hole right when it started beeping, so we are ready for that next post. Ooh. There it is. Nice flat bottom. Now for the finesse. The very controlled lowering of the log into its hole. Just settling the gravel a little bit. It's sharp gravel, so it actually can compact. If you had smooth gravel, it would sort of act as ball bearings. But sharp gravel is able to, the edges will lock together. So you tamp it, and so settle the gravel, and it will hold the post in place really steadily. And just like that, we have a very solid post.
Okay.
Remember geometry?
Nope. You?
Nope.
This is the final product. This is the beginning product, so
Right, okay.
we'll start right here.
Okay, cool.
Once and for all. Try this side.
It's the reality of being 6 weeks in. Tomorrow's the 1st of October, and we're still, only about a quarter of the way finished with the build. It's pretty daunting. The skill that would be required to make the project go quickly is just not there. I feel capable of doing it, but I don't feel capable of teaching 6 people how to do it and having 6 people work on it all at once. It's more like I just need to work on it, and I'm pretty slow. But that's I guess what I signed up for is a challenge. So now I guess we just have to keep on doing it, keep on moving forward. Now that I have the top of the post and the depth scribed, so I'm using this square to scribe the vertical part of that notch, which I want to be at 90 degrees to the 24 degree top. 1 7/16. 1 7/16. So the reason we have to make these notches first is so that we can then have an accurate measurement for the distance between the notches. So then we can take that measurement and then go and scribe it on our beam So when we cut the flats on our beam, it'll match up perfectly with the tops of these posts. Taking all the measurements on the notches across the top of the posts, we are going to carve up this rafter, put some corresponding notches on this rafter so that it will fit across the top of those posts. To do that, we are going to mark the ends with a level line and a vertical line and center that will base our string of notches across. Using my chalk line to mark a square line. So I'm going to start with the east side. Sun rises in the east. Okay, so the notches on the top of the posts are angled so that none of the notches on the rafter need to be angled. So everything on the rafter will just be 90 degrees. Straight down, straight across, straight down. And that really makes it a lot easier. Chainsaw guide. Don't want to cut too deep with that thing. Once you take the wood out, you can't put it back. And that is about perfect depth. Now we can use this. Check the level of that bottom of that notch. And that is level. It doesn't remove any strength from the post to have the top be angled. You know, if the notch was at a 24-degree angle or something like that, then you would remove like a third of the girth of the log.
Right.
So that's the reason to try and keep these notches as straight and shallow as possible.
That makes sense.
That's why it's good to make a video that has all your techniques in it, because then somebody else can watch it and they can see how dumb you are, and then they can go and do it better. Now it's time for some purlins. So we have the crown down here. It's oriented with the crown pointed down. And this is the plane that our notches need to be parallel to in order to keep the crown up when it's installed in its final position. So we're going to rotate the purlin so that it is, the notch plane will be level so that we can use levels to align all our notches. Hey, 1 3/8. My favorite measurement. Like everything is always 1 3/8 with this.
Oh, I thought you said Wednesday the 8th.
Time is moving faster than I can comprehend here at Wheaton Labs. The purlins are actually supporting the roof.
Mm-hmm.
And the rafters are important because they tie all the posts together.
Mm-hmm.
But they don't actually take a lot of downward force across their grain, because that force is coming directly on top of the post, being transferred directly through the rafter into the post below it.
Yeah.
And so the purlins are going to be on top of the posts. So 7.5 inches.
It's a lot of wood.
Times a foot is a lot of cross-sectional area for tying the posts together. As much as I don't want to remove meat from the rafter, I much less want to remove meat from the purlins, right?
Right,
because the purlins are actually holding the roof. We can't say over-engineered because none of us are engineers.
To make it as bueno as possible.
This is the first prototype of this purlin notch, which has a flat and then a saddle notch to receive the untainted round wood of the purlin will sit in here. And what that does is it gives us a good flat for contact and anti-rocking, as well as conserves the entire girth of the purlin, which will rest right here. The technique for scribing these notches is to, first of all, orient your log with the crown in the position that you want it to be. In this case, it's crowned down because this is the bottom of the purlin, and so when it's installed, the crown will be up. Then we take a level and make a level line across through the center of the heartwood, measure to find the center of that line, and then use a framing square to mark a vertical line. That gives us this point up here, which is the center of the log. At that point, we can snap a chalk line across that will give us a point to make square cuts. You can use the framing square along the chalk line to make a square cut across the log. Or what we'll do now is we've marked that this is the width of the notch, 1 3/8 deep and 7 5/8 across. And so that gives us the measurement to make the flat on the rafter that this will sit on. And then once we've made those flats, we can measure and then transcribe those measurements onto this log. In order to do that, we need a couple more chalk lines. Over here, I've got 110 and 110 3/4, 110 3/4, and 117 flush. And let's go to the south side and make your 1.5 inch. So now we have this point and this point. And if we connect those with a line, that is where we will cut for our notch, and the notch will run from that line to the end of the log. We've got the saddle notch and we're ready to put the purlin in. We want to shape the notch so that if it gets rained on, or once it's finished, if there's a condensation issue, that water does not collect inside the notch. So the complete line be like this.
Real nice. What a nice fit.
These are going to be posts for the wing walls. So we're about to install the 2 triple posts. So it's a post at a corner junction in the wing wall, and 3 individual logs will support the joining of 3 rafters. So we're about to drop those in. Here we have 20 degrees and snowing. And we're trying to do some timber framing under the tarp.
You should say something cool while you're standing up there. That's a great pose.
This rafter's ready for a spike. Here, hand me the drill. So this is the west wing wall on the Wofati greenhouse, and we just installed these retaining wall logs and then put a little bit of plastic up against them, and we'll backfill some earth behind it.
It's been fun. I've been here, what, almost 4 months now?
Yeah.
14 days.
114 days. It's a lot of days.
Yeah, and I got to learn so much about the timber framing. I came in with 0 experience. Now I know how to make a horizontal brace, an angle brace, and a bunch of notches, and measuring for rafters.
Yeah. One of the things that I've really appreciated about working with you, Des, is just that your attention to detail is even more meticulous than mine.
Oh, really?
Uh-huh.
One of the ways that I appreciate you is like you can be meticulous, but you're also versatile. Like you can also be the opposite end of the spectrum,
Right.
where it's just like just get it done.
Yeah.
fast.
I know when it's not important to be meticulous.
Right.
Yeah.
Yeah.
When you get the diminishing returns to the
Definitely.
attention to detail. I mean, that's been one of our biggest struggles, I think, with this project is sort of like, what is the level of quality that we want? There's an aspect of the project which is very much, it is an experimental prototype
when you're working with a prototype, the faster you can get the first prototype finished, the more you'll learn from your labor.
Like the sauna.
Versus like doing something really well, but it ends up being the wrong design.
It's a prototype anyways.
Yeah. Right. Yeah. You know, the greenhouse design it's the first prototype of the greenhouse, but what it's not a first prototype of is our construction techniques, our roundwood timber framing techniques. This is like a fourth, prototype. The motivating factor for me to increase the quality of the timber framing is based on my experience of having to remove failed structural members. So whether or not, they rotted or, a lot of the things failed because they just weren't peeled, or the joinery failed because a round piece was attached with a screw to a flat piece, and then that round piece rotated and broke the fastener.
Yeah.
And so, that I've seen that in the previous prototypes, and so I have this desire to, learn from those mistakes.
Definitely.
That then creates this conflict, trying to do a high standard of framing on a project which is ultimately a first prototype. Anyway, today it's beautiful out. I crushed my toe with a log yesterday, and so I am on one foot, hopping on one foot. Construction on the second and final wing wall begins today. Pretty exciting. You ready?
Born ready, baby.
Bing! So now that we've figured out how to build one wing wall, we're going to show you how to build the next one. This is Dustin. He just showed up to help us out for the next couple weeks, our final stage of the timber framing. You got any immediate thoughts or impressions?
Looks pretty cool.
So we got room for like a couple more rocks.
What we're using now to determine the height is the laser level in reference to the rest of the structure, and that's how we determined it needed to go a few inches deeper. So I'm going to bring the excavator in here, be able to grab those posts and swing them over and drop them into these holes. When we set them, we want the back edge of the post to be up against this string line. So on top of it, there will be the horizontal beam that will rest across these 4 points of contact. So we're using the string line to line that up. So some of you have been here for a very long time, and some of you were here even before that. And that time has included many posts, setting of post after post. I mean, it's more than I can count. And here we are today. We find ourselves with the final post about to be set. Ready to be post to post. Got me.
Let's do it.
Golden word. Post haste.
I can't.
On three, let's do it. 1, 2, 3, let's do it!
Woo!
This mark, the string line, was based on the top of this log, and we will be notching this log down 1 inch to create a flat for our beam to rest on. And so now we're going to take our entire beam and drop it down 1 inch.
And so this will be, it'll be 1 inch deep from the point of the string line here, and on each of these marks we can take our little ruler and you can scribe a line 1 inch down below that. And we'll go and transfer that onto the other one as well. There it is. So this will be the top of the notch, and then we'll actually install the main boards that are the saw guides 1 inch lower than this even. And then we'll use a spacer to bring it up to 1 inch for the top, and that allows us to get the notches on the on either side of the post in plane with each other. You can screw that one in. Screw the 1 inch spacers in, cut these off. So 1 3/8, and then hop in here and get our perpendicular line. Here we go. Nice and in plane. $1,000,007, $1,000,008, $1,000,000.
What you got? I got 27 1/4. Alright, nice and easy. Really close. Move it to the left a little bit. Okay, you guys got it.
Two, three. One, two, three.
When I first came on my first day, I was like, man, it takes a long time to just put up like one rafter. And then boom, we got 3 up in one day. So
So now that we've mostly finished up the framing, we're going to transition to working on the retaining walls and the roof. You can see there's a couple little air gaps there. We're going to close those up, and then we'll be ready for cob over the roof and the membrane. and then earth.
Yep, push it in. 1, 2, 3.
Excellent. Our general technique for installing roof poles and retaining logs is pretty simple. The pole is rotated so its bend nests against its neighbor, like a spoon. Knots or branches are shaved to allow a good fit. Then, a fastener is used to hold the pole in place until the earth is added. The primary fastener is gravity, once the weight of the earth is resting against the roof or wall. We've been putting a single 3-inch screw, just a framing screw. We countersink it so that we can get it with 1.5 inches in the roof pole and 1.5 inches in the rafter underneath. And now we're gonna go back and install an 8-inch timber lock in every 5th roof pole.
What you doing up there?
Looking for holes.
Looking good.
After tomorrow, I won't be able to touch any of this, so gotta fill all the gaps in. So now that we've finished softening up all these edges, we're gonna come in and put a layer of cob over all the retaining wall logs and roof poles that enclose the interior portion of the greenhouse. And that cob will fill in the cracks as well as prevent these gaps from becoming rodent space. And it also holds up against the plastic and prevents the plastic from being a medium for condensation to happen on. We're really excited because a bunch of the folks who are going to help us today have never worked with cob before. This earthen mass is going to get piled up on top of the primary membrane that's over the interior space of the greenhouse. I'm going to set these stakes as a depth gauge for how much earth I'm going to add. At this stage in the build, I want to add about 18 inches of earth above the top of the roof at this back corner, and then it will decrease in depth as it moves up the structure. This upper portion of the roof, it'll only be about 2 or 3 inches thick. Today we're preparing the mass to be covered by the umbrella. So this earth that you can see behind me is the dry mass on the north wall of the greenhouse. This piece of plastic in front of you is the umbrella from Allerton Abbey. And we're going to run the greenhouse umbrella right up and tuck it underneath, so there will be continuous plastic between the two structures. They'll meet here at this high point. So for the wing walls, we've installed this black plastic on the vertical wall, and it's laying over a little bit onto the roof. We're going to run the umbrella from the top of the roof down onto this sloped earth, which will drain water away from the posts that hold up the retaining walls. It's coming. Another couple shovelfuls right here. That'll hold a lot better than if you spread the whole shovelful across the plastic.
That's one plastic covered mound.
So we have waited to do any of the exterior wall treatments, the wood or the glass that'll enclose the space, until after we have the full weight of the mass and the umbrella up on top, all that earth. That's really important because roundwood likes to shift a lot, especially you know, as you start to add that static load, that earth up on top. A lot of the joinery has kind of sat together and sucked up, gotten a little tighter. We want to get that shifting out of the way before we install our fragile glass, which doesn't want to be, you know, warped or twisted at all. And that'll allow us to have better seals on our exterior enclosing walls. So the next step is cutting the roof edge. We want it to be true east-west and square to the front wall. This is a little bit difficult because the structure, as it's been being built, the round wood has made it slightly out of square. In order to square it up, I cut these front wall posts in level and in plane with each other, and then installed a 2x4 here at true east-west. And then I built this scaffolding, which is all square to itself and square to the 2x4, and that's going to help me establish this string line, which you can see is now based on the scaffolding, and that gives me my true east-west line. So what we need to know is this dimension.
Yeah.
X. Finally got the order for the glass in, and that'll show up in about 2 weeks. And we're going to take advantage of this lovely weather. We're going to install the front umbrella and do a final grade for the front, including the access road that's going to run right through where I'm standing here. And then we'll build that framing for the glass. So we've got a gentle slope away from the structure. We're going to backfill with a nice pad of gravel. These are some pretty big rocks that you're working with.
Yeah, some of them need 2 people. This rock is like a foot thick. Only 6 inches of it is exposed front. So as I fill in with gravel, the stone will get locked in. So as you're walking down, you're not shifting them. They're not going to slide on top of here. If they were only 6 inches, they have a chance of moving.
Yeah.
So now they're all locked together. Oh, that's better. The pieces I want.
Choosing the pieces for this step.
And then I'm going to bring them up to the right height and tamp down the base. Pretty close. I might adjust it, but it's nice for now. I like to check the level. Might work. So when we started, we had our base layer at the right height, and we took a laser level measure. 6 inches up, and then I just measured up 6 inches from that to get each step height. So I have a reference. So I'm measuring off this single reference, and checking each step. They don't have to be perfect because they're not flat. Just about right in that spot.
So you're using large bits of gravel to
Yep.
wedge between the large rocks to settle them in the position you want.
Yep, and then as long as it's stable, when I fill this edge with gravel, it won't sink and it won't rock.
So now that Kyle finished these lovely stairs, we have to finish the grading up to this point. This will be the highest point, and we'll lay the membrane down, the umbrella over the front, so that any water that falls in this area will flow out and away from the structure. Now that the umbrella is installed on this front side, we're gonna backfill all the way up to the structure. We buried the umbrella extra deep so that when we come over and build this road, the road's gonna go right about here. And we wanna make sure that that umbrella, that membrane, is down several feet below the road grade so that the road is still able to be stable. But it's important that there's a little bit of contact between the cob and the wool, because the wool will stick to the cob and that'll help to hold the wool into the space and prevent it from sagging and like leaving air gaps that are not insulated. So the more that it gets stapled, the better it will stay at being spread throughout the entire wall cavity.
Have a hearing protection, especially if you're the operator.
A couple things that are valuable that I like to tell people first time that they're working with cob: the less you touch it, the better. So if my hand is the vertical wall that I'm trying to cob onto, if I just do a single smush, it sticks really well. But if I go and I start patting it, you can just see it detaches, right? The other thing is that we like to apply cob in relatively thin layers, so it's going to crack. If you just apply one thick layer, then you have really thick cracks, and the whole thing will come crumbling off. If you apply multiple thin layers, then the cracks will never overlap, and you'll be filling in the crack on the last layer when you go in. How was that? You want me to do it a little slower?
Yeah.
Alright, one more, a little slower.
Oh yeah. There you go.
So you can kind of see the general technique, right? Yeah, it's pretty straightforward. Focus on just getting the cob on the wall. Doesn't matter how much you end up dropping. We can pick that up and reuse it.
You want a good smear and a right thickness.
This is your first day ever cobbing? Working with cob? And you said it's your dream?
It is, yeah.
Awesome.
Been waiting for this moment for a long time.
What about cob? Like why is working with cob your dream?
Well, I really like the idea of building my house myself with materials that I have easier access to. It's more affordable, and just the creative freedom, and something about it also just seems really sentimental to be living in a place where you can like see you and your friends' handprints on the walls. And yeah, I don't know, I also like the dirty factor of it.
It might not be as much fun as squishing the cob between your hands, but it sure looks like you're working faster.
Much faster, and it seems to be a more consistent technique also. Yeah, I mean the hand smashing, in some ways it's easier because it's all in your hand and you can kind of sculpt it and mold it as you go, but this just produces a similar result every time, it seems. So yeah, I'm liking it so far.
So we've just about finished up the framing for this south side bump out that will support the glass. We opted to go for a 2x8 stud wall underneath the glass. That gives us more room to pack insulation, have a higher R value for this front wall. We've framed in a ventilation port here down low. And then on the east and west sides, we've got a 2x6 stud wall that also has a ventilation port. We did 2x6 here so that we would have, again, more room for insulation material. And then on the front face here, we've got this plane that's at 64 degrees, and that will hold the aluminum glazing track and the glass. So from the inside here, you can see that this stud wall rests on roundwood posts. We've got 3 posts that run across the south side of the greenhouse, and this 2x8 just rests directly on top of those. So from the outside, it looks like this stud wall just starts at ground level. And that's because we've got this log retaining wall up against those posts. And we've cobbed between each of these logs, and then between this top log and the bottom plate of this stub wall. And we've got this plastic membrane which runs on the outside of that log retaining wall. It's a vertical plastic membrane, and that is going to come up and get tacked to the front of the stub wall. And then the umbrella, which runs sloped away from the greenhouse for about 20 feet, that is going to run and tie directly up to this stub wall as well. So then we're going to add a piece of aluminum flashing, a drip edge, that comes over the top of these plastics and slopes out and gives us a nice little drip edge away from the structure. And the siding will be installed on top of that. One of the techniques that we have used to try and seal this structure is when we're transitioning from roundwood to dimensional, we've frequently had to carve a flat face on the roundwood so that we can couple a dimensional board up to it. And we've done that in multiple locations. You can see it here, you can see it down here where I've installed this one at the sill board here. When I was first designing the structure, I didn't have a whole lot of understanding for how the roundwood timber framing would transition to the dimensional, and it represented a large problem in my mind. And that transition hasn't always happened very cleanly, and so you can see here where the roundwood creates these odd-shaped gaps that we've had to fill with random puzzle pieces that we've cut custom for that hole, and then fill the gaps in with cob. That's been our technique. And now as we go into weatherproofing the outside of the structure, we're gonna tuck plastic up over the top of those and then cover these up with our aluminum drip edge. And that'll hopefully prevent any water incursion into the outside of the structure. While we've been cobbing, you've been over here building this door in the secret.
Yep.
Can you tell us about it?
Sure. So I'm building up the core, the structure of the door first, so then I can put the tongue and groove boards on the front and back. So in the center, in the core of the door, I need great big pieces of wood to screw the hinges into. They're going to go into this side and into that one. So I've built these 3 layers of 2x6s into both spots, and those pillars are going to tie into the angle support here and there to help prevent any sagging. So the hinges will directly operate on these 2 pillars and hopefully prevent any sagging or wobbliness in the future. Point out the parts of the door right now. This is the actual door frame, the separate door jamb. This is the door. This is like the core structure of the door, this frame here. And this is the angled support. So is this. And then the 2 pillars where the hinges attach. And then I'm going to box out around the latch over here. So this is an open space for the whole latch mechanism. It's not ready yet.
How close is it? How close is it? Just got to make it a little thinner.
Yeah. I'll bring it down with the sander. So first thing I did to make the gear, I made the shaft and then put the teeth in at a 90, 90, and that's 45 one. So I've spaced them out evenly. And to get the gear pattern, I traced out the path they travel in a wheel-like fashion. So I'd mark the height and the height and the height and where they sit when they get near the edge, and make sure I keep it in the same place, and just rolling it back and forth and watching where they pass. And they kind of did like little curves, and eventually I just squared it up, made the teeth square, spaced it out, and copied the pattern. I tested different cuts and actually tested how it felt rolling, and found one that worked better and put it on the piece of wood. I had to make that deeper, but
wow,
it works!
Amazing.
It looks like a door. Hope it fits! I tried to use the crowbar to lift the door and see if the hinge had any play.
Yeah.
It would not move.
Wow, just glides soundlessly. Going nowhere.
No. do all the insulation. And oh yeah, we have a full opening. You can see 4 bolts going through to the fronts of the hinges here. So those go all the way through the door. They are full thickness, they're full 2x6s, and then they kind of attach to the diagonals, which will help any future sag if the actual frame wants to slump. They're going to prevent the this right angle from changing.
The sheathing on the outside is also angle bracing.
The sheeting on the outside goes the other direction, and that has a whole ton of nails in it.
It's nice to build a little hook to hang your saw on. Installing a little top cap here that the flashing, which directs water from the roof edge over onto the glass, will rest on top of this top cap. And it's kind of a weird puzzle piece that I made with the table saw. Hopefully it fits nicely. It's looking like it does. Glazing track piece will fit nice and flush, and there's this little gap here. It's important that everything that's going to have water landing on it is sloped appropriately so that water will drain where you want it to. And so in this scenario, the facade is going to come up against this edge with a little rain cap over the top of that, and then there will be flashing underneath the facade that goes over the top of this piece, and the flashing will drain onto the top of the glazing, and so that if any water lands on the top cap, it'll go down and over onto the glass and away from the structure. So this glazing system that we're installing, these extruded aluminum tracks, they come as stock materials. It's a product called ProSeal that comes from a company called Abundant Energy Incorporated. And what it is it's this extruded aluminum track that we can then cut to be the appropriate size for a rough opening. And it has these neoprene gaskets that the glass will rest on, and then a gasketed cap that screws down on top, clamping the glass in place. The beautiful thing about this system, especially for us, is that it has this condensation harvesting gutter on the underside, So any condensation that forms on the interior face of the glass will run and collect in this gutter, which is then routed to the outside of the structure through a series of weep holes. We want this glazing track to be installed perfectly square because the glass is perfectly square. The framing is just a little bit off, and so the top base bar is parallel to the framing, and then we use diagonal measurements to locate the bottom corners of our vertical base bars. So now we're going to install this. So the glass actually rests on these setting blocks, which have a nice rubber gasket, and that fits right inside the extruded track and screws in. There's 2 of them per pane of glass. Roll my sleeves up so it looks like I've been working.
Who's been working on this building? Certainly not Josiah.
The guy's standing around all the time, scratching his head.
We do a lot of head scratching.
Somebody's got to do it. Take 3. The technique that we're using to seal this roof edge is to bring the membrane plastic over, pull it nice and tight up against that dimensional 2x8, and then we're going to seal the plastic on and protect it from weather with these millins from our sawmill. These are 2 little scrap pieces that I'm using to show you, but this piece will protect the front edge, and this top cap will protect the plastic from sun and provide a drip edge to either side to help protect this piece from weathering. So we're pushing dry earth up against that roof edge, and then we're going to tuck the umbrella up over that so we've got a little bit of dry earth that smooths out the slope and acts as a little bit of an insulation on the roof all the way up to the roof edge.
Very nice.
Yeah! My fun meter, it's you know, it's all the way at max right now. Alright, up it goes. Nice, nice, nice. Move it a little bit towards Kyle. That's good, yeah, yeah. You can sit on those blocks.
Okay, it's on.
You got it.
Yep. Down it goes. Down. This is the one that has the most questionable fit.
Do you have it, Josiah?
I do, yeah.
And
1, 2, 3.
doing a sunflower. So yeah, right now I just have the center of the sky.
I wore through 2 new pairs of pants. These ones are about to be the 3rd. At least 1 pair of boots. Certainly wore through 1 pair of suspenders. About 6 pairs of sunglasses. And we're done. These mill-end pieces are doing a great job of protecting our plastic membrane where it comes to the edge of the wall. So this is the roof edge effectively, and it's got a little drip edge carved on the underside, so if any water wants to run underneath, it'll strip off. Everything about it is kind of designed to protect the plastic and the wood underneath. So these parts are essentially disposable. Hopefully we'll get a good 10 years out of them before they'd have to be replaced. There's a good chance that we'll oil them. The function of the wing wall is to hold the earth away from the front wall. So, you know, we've got this earth mass piled up around it, and in rain events, you want to prevent anything from wanting to run around to the front of the structure. So these wing walls do a good job of being slightly tilted out, and they're retaining walls, so they're holding the earth back. So everything drains away from the front, and we're not going to have any erosion coming up over the top here. We wanted to keep the roof angle very shallow, so everything is about a 20-degree angle. So 3/12 or 4/12, somewhere in there. And that's going to prevent any of the earth that's on top from wanting to slide away. We've had some problems with other roofs that are a little bit steeper, getting up close to 6/12 or 12/12, and the earth really doesn't want to stay up there when you have it that steep. So all of the roofs on the greenhouse are that 20-degree angle, or 3/12. We've used this technique with dry stack rock in multiple different places on this build. One of the ways that we're using it is here at the end of the wing wall, where there's a 2-foot drop between this corner and ground level. We used the dry stack rock to create a retaining wall that'll hold the earth away from this walkway, hold it away from the front. The building is oriented solar south, so the glass is pointed due south, and it's also, the glass is tilted at 64 degrees, which is perpendicular to the angle of the sun on February 1st or sometime in November. So it's oriented and optimized for fall and spring. Let's go check out the inside. cold sink here is 6 feet below the walkway, and then the steel well casing goes down another 20 feet. And we've been referring to these as thermal wells. Inside the thermal well, there is a black poly pipe, and on this side it's 1.5 inches in diameter, and on the west side it's 1 inch. This black poly pipe goes up and underneath this grow bed here, and transitions to copper pipe painted black, and those run up underneath the window. Those are the destratification pipes. The theory is that the sun's going to hit those and they're going to cause convective flow that'll cycle air inside the greenhouse all the way from the bottom of the thermal well up and through the top. I just installed them yesterday. I have no idea whether or not they'll work, so we'll find out. This is my infiltration box that the gray water intake pipe goes into, and there's a 1x8 just laying leveled on top of the wood chips, and so then it hopefully spreads the flow of gray water where it runs through the wood chips, and then we'll have a bunch of wood chips up on top, and hopefully that'll just make it smell nice. I don't know. So then this guy, it's not supposed to be difficult to remove. There it is the lid for the drain inspection. So at the bottom of these buckets there's little 1/4 inch holes drilled all the way around, and then they're just sitting on the bottom of the tub, so water should be able to flow underneath the bucket and around. And what that does is that we were trying to figure out how to screen the drain in a way that allowed for easy removal of biofilm. So it's gonna clog itself.
Right.
And so in this way, if it's like maybe monthly inspection, it's like, is there biofilm everywhere? Maybe take an old toothbrush and like wipe the inside there, or just see if there's still stuff able to go down the drain. And so it's easy to access for inspection or maintenance or cleaning out. I have no idea what the failure modes of this system are going to be. I can imagine some, but I'm sure that's what's going to happen once you start putting gray water through here is going to be different than anything that I can imagine. Welcome to the greenhouse, Paul. This is your official tour
of the final product. It's all done. There's nothing left.
I'm not going to do anything else.
Okay. Okay, so like right now it's a sunny day. It's a beautiful sunny day. I want to see how warm it is inside, and I want to see how many of our experiments are starting to work.
Okay.
And so I know that this is Magdalene's art. She didn't want to mark it up, like right here on her art. This is art by Magdalene.
No, I think that creating the art was enough of a marker for her. Yeah, so it's hot in here already.
Oh, I love what you did with this. Oh, so I can see the drain.
Yeah, or reach in there and clean it out if you need to. You're the only person whose arms are long enough to actually reach to the bottom.
I can reach to the bottom.
That's amazing. I can't.
Oh yeah, so it'll be my job
apparently
to get the muck out.
You know what's just really funny while you're standing here is that you look kind of small inside of the greenhouse.
I can't reach the thing up there. I can't hold my hand. It was blowing.
Yeah, I don't know how it got to be so big.
So this one's 1.5 inches.
Yep. Feeling anything?
No. I might feel a little bit over here. But yeah. Well, it's definitely metal. I kind of want it to be blowing, like with the sun hitting it right now.
Right.
I want it to be just super blowing on it.
Wouldn't that be awesome?
What if we had some mirrored half pipe?
Yeah.
and that was kind of mounted behind it about an inch.
Hey.
So extra sun hits, and it gets triple sun than this space gets.
Right.
So it heats the pipe even more, because when we need it to work the most is when this space is super hot.
Yeah, totally. Well, wouldn't it be cool if the person who installed it with a nice big block that you could easily mount a parabolic mirror to?
Oh, I see what you're saying.
Hey, look at that! Oh, wow! There's room here to mount a parabolic mirror behind it. It was like I was thinking that might be something you wanted to try.
When you go down there, is it really cool down there?
It's pretty nice, yeah.
I feel like the hatch is so that you can go get your keys after you drop them.
Exactly. Yeah, there you go. Yeah, that's a good point.
And if you drop your keys just in the right spot, it sucks to be you.
Yeah. You still have this effect of, like these walls are all insulated, right?
Yeah.
But this wall is, it's not insulated, and so it's just absorbing your heat, your body heat, and whatever.
Where's the little thermometer that tells us about the mass?
That's right here. It's mounted to the side of that frame.
64.9.
That's the mass temperature.
So right now, that feels like, well, 64.9 is pretty close to room temperature. That feels like room temperature.
Mm-hmm.
Like it feels cooler than out here.
Yeah.
It feels much cooler than that, which is in the sun. Feels about the same as this tub.
Right.
So you made a kind of a lid.
Oh yeah.
So that way we can look at the drain and clean the drain if it ever needs to be cleaned.
Yeah, so you can see the drains on each of these tubs, and then at the bottom of the bucket on the outside edge, there's 1/4-inch holes drilled all the way around.
Oh, okay.
And so the water can infiltrate.
Oh, right.
Subsurface infiltrator right there. So the gray water will flow into that box, and there's a baffle along the bottom, so it will spread hopefully, and then infiltrate into the wood chips, and we'll see what happens. We started this idea questioning all of the assumptions about what were necessary to have a functioning gray water system, because we have to invent something for this climate. And so, throw all these assumptions aside about existing systems, and what do you come up with? And it's like, well, this is kind of the most simple thing that I can think of. It probably is going to fail, but at that point you can determine, okay, why did it fail? Do we actually need to engineer the system differently, or does it just need something, a slight optimization? It's interesting to try to come up with a design for a deck that allows lots of airflow through it and is also not scary as hell. I feel like we kind of reached a little bit of a happy medium here. It's like, it's kind of terrifying.
No, I think the spacing is really good.
Yeah.
And I think that having light hit that area down there is brilliant, because it takes it a step, that alone takes it a step up from Mike Ayler's designs.
Right. I've wondered how to insulate the ceiling of a Wofati. Because it seems like there's really not enough mass up top to justify it not being insulated. And I think that it would add a lot of benefit and temperature stability throughout the winter if that ceiling was insulated. I think this technique might work, because you can put your spacers directly up against your roof poles. You can start installing lattice work enough so that you can stuff your insulation in there.
What do you do about where it says Tater Tot? You don't want to cover that.
Well, you don't have to do it in
Greg
here.
Martin, But yes, I think that if we were to put in some sort of insulation to here, I think that would help a lot. I also think that what would help a lot is when we plant stuff on the roof, if we put down thick insulation.
Lots of mulch.
Lots of mulch.
Yeah.
Yeah, I think that that's going to help a lot.
Yeah, pretty cool. Well, thanks for stopping by. Personally, I feel amazing having reached this sort of arbitrary milestone of the end of new construction and the beginning of remodeling.
I think your next 15 years are going to be packed with a dozen people a year asking you to come build them one.
We'll see.
Yeah, you're going to be a busy guy. I think. I could be wrong. We'll find out.
Yeah.
Love the door.
It's so nice. Such a pretty door. But yeah, I think it turned out probably a little bit more finished product-esque than we were originally imagining.
I think it is a thing of beauty. Oh, it's cool out here.
Now that the build's done, we're ready to begin testing. What's the winter gonna bring? What's gonna happen? Who knows? We'll find out.
I predict cold. First, we never had a freeze in the greenhouse. All winter. And at one point, the temperature did drop to 12 degrees below 0 Fahrenheit. Success! Ha ha! But it gets better. Much better. When construction was wrapping up, Josiah popped tracking thermometers down both of the thermal wells. Both held a rock-solid temperature of 46.2 degrees Fahrenheit. We dropped the destratification pipes in, and no change. When the sun was shining on the pipes, the air didn't seem to move. On August 27th, we added reflectors on most of the pipe exposed to the sun. We then saw the west well rise to 48.5 degrees Fahrenheit, while the east well rose to 48.0 degrees Fahrenheit. The west well is using 1-inch destratification pipe, and the east well is using 1.5-inch. It sounds like the 1-inch pipe is the winner. We then added more reflectors and some insulation to the east well pipe, and it quickly caught up. Sort of. The east well rose to 48.1 degrees Fahrenheit, while the west well dropped to 48.2 degrees Fahrenheit in mid-February. I think this is the effect of all that cold accumulating. We then improved the reflectors and insulation for both wells, and both wells are still dropping a little. The east well is now at 47.5 degrees Fahrenheit, and the west well is at 47.7 degrees Fahrenheit. So they're still much higher than where we started in July of 46.2. During a sunny day, the temperature in the greenhouse rises, and that warm air is slowly pulled down into the thermal wells. At night, if the greenhouse temperature drops below the temperature at the bottom of the wells, the colder air falls to the bottom of the wells, forcing the warmer air up. Let's look at the temperature of the mass on the back wall. It started at 64.9 degrees in August. I would think that mass would be much warmer 2 or 3 years in. The mass cooled slowly to 41.7 on March 14th, and it has been slowly warming ever since. Overall, the cold does slowly penetrate, but the combination of heat from the summer plus the power of the destratification pipes wins the day. Further, I suspect that each year this whole system will get warmer and warmer. My guess is that next winter the greenhouse will be about 5 degrees warmer than last winter. All of this data adds up to, I think, we have a strong success. One last interesting bit. The tracking thermometers also track the relative humidity. There were several times when the humidity was pegged at 100% or just very high. So the thermal wells also act as dehumidifiers. Congratulations to Josiah and the Permaculture Bootcamp for this big win. The people in the Permaculture Bootcamp come to experience gardening, natural building, and a lot of other things. which is why I have a rule that nobody works on any one project more than 4 hours a day. Compounding that with a lot of other bits and bobs, this meant that this project got worked on for about 3 half days each week. And that's just when the weather and other happenings allowed it. Josiah learned roundwood timber framing at our events and in the permaculture boot camp. He had been here for about 9 months when we came up with this project. I added a lot of experiments to the idea, which will make it take longer. In the end, I think he did a damn good job. This is Caleb Larson, timber framer. How long have you been doing the timber framing thing?
2005. Full time.
17 years. 17 years full-time timber framing.
Yep.
Man, that's impressive. So, years have passed. We've built some more structures. We did a lot with the berm shed. A lot of roundwood timber framing in that. And then this is our latest thing. So basically, it's our collective knowledge accumulating over the years. We're getting better and better and better at this. But I suspect it's still not to your skill level. And I mean, for example, when we are doing this, we're still using metal. We're still getting, we're putting metal pins in that we're getting from rebar.
Yep.
And it's like, let's just be safe. Let's just do that. And it's like, I can think of some joinery where we wouldn't need it. Or where if we really wanted to, we could get like a 1-inch wooden dowel and shove that in there and be like, good enough!
Yeah, the joinery has its place, but steel is fast and it works. I'm not quite as much of a purist on the all wooden joinery as I used to be. After years of running a business, there's times where a screw and a lag bolt or a rebar and a pin, we don't get to use just rebar that much, but a lot of all thread and things. The engineers like that.
Okay, all right.
So I think you're right on. A mortise and tenon joint in roundwood is very difficult. I've done a bunch of them for fun. I've never had anybody who wanted to pay me enough time that it would take to actually do it.
So I kind of feel like there is like if you do it without any metal, pure joinery, all wood, there is this sensation, I'm going to heaven. Because of this.
Special craftsman Valhalla or something. Yeah.
Yeah. The thing is that if it wasn't for this, like if this bit of wood here was not there, I'd be worried that a split would happen and this piece of wood would break off. I'd be worried about that. And I've seen it happen a couple of times. And so I always insist on these shoulders now. I don't know if you ever do any of that.
I would be curious to see where you saw it split.
Whether it was just a check or whether it was
sometimes
like
they're checks. Because if you think about it, I heard you guys talking about it in the video too, not wanting to compromise the bottom. But if you really think about the cross section, that piece, I mean, you're the equivalent of what, like a 1x3? You know, you're not really taking that much pressure, but it does create a pressure point there. It is possible. These logs are pretty round. A lot of stuff you end up with such irregularities that it can't roll because of this scribed shape. I mean, it fits perfectly.
That's true.
When you're done. So if you have a oval shaped log, it can't twist because it's getting wider.
So for like this, you would put a saddle here and you'd leave this log nice and round and just drop it into the saddle.
Potentially, yeah.
And then
you can combine that with some flats and different things too, and some more advanced joinery if you need it in that situation.
Right, like there could be a case where something wants to be wobbly for whatever reason. Yeah. And but for a lot of this, saddle. And then what you're gonna do is you're gonna scribe it out.
Yep.
And then you're gonna come in with a chainsaw and go choppity, 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 choppity.
Yep.
And then you're gonna take that wood out.
A lot of it with the chainsaw. A lot of it's just being good and careful with the chainsaw. So
you're going choppity choppity, and then you're going to go choppity between those two chops.
Yeah.
Like you're going to make
and then brushing it, which I did see Josiah at the end. I saw he was starting to brush things out. That was one of my comments when I saw it. He was doing a lot of time with the chisel, and I was like, man, you can do that with the chainsaw. And I saw by the end, he had figured it out, and he would sit there and fan it back and forth on his flats.
Yeah.
And that's kind of the trick.
So we've got the thing where you would do a lot of saddles. There'd be a lot more saddles here.
Probably, yeah. I think it would be a little faster, potentially.
Okay. So I kind of feel like putting a saddle into the end of a post makes sense. You're not going to lose any strength.
No.
But when you put a saddle into this, you're cutting into that log. You are weakening.
Well, it would be
this
into
structure.
this one. It's going to have to come from somewhere. I mean, essentially, you flattened it already.
See, now if I put a real shallow saddle
Yeah,
in,
they don't have to be huge.
yeah, I could be okay
I mean,
with the shallow
if
saddle.
you get enough bearing, it depends on how much bearing you need.
So whatever joinery is done, you agree, keep it shallow. You don't be digging deep into that wood.
The only thing I would say we're not shallow is the top of the columns. If you're gonna do that,
Yeah.
saddle not because
Go
it doesn't
crazy.
matter. Yeah,
Go crazy.
I think an 8x8 like timber post will hold something like 60,000 pounds, or it's something so insane.
Phenomenal.
You're never gonna put too much pressure down, and that captures it. But that's a different scenario. Yeah, you're fully there.
And for spots like this, you're super keen on doing the saddles, but your saddles might only be an inch deep.
Yeah, potentially.
Yeah. Okay. Here is my Ayler style trench.
Yes.
It's a bit larger because I want to harvest more. And I also think that the gaps between my wood is larger, so I can have a better air exchange.
I think the gaps are perfect. You guys had said maybe it was a little terrifying, but it seems perfect to me.
Yeah, I think this is great. I mean, so in the boot camp, I don't know, we're pretty good when people have proven that they've got some skill and they want to try something interesting like this. We say,
Get creative,
"All right,
have
go
fun."
ahead, have fun,
Yeah,
have a good
I love it.
time. So
Yeah, I love this
Kyle-
supersized mechanism there too.
Yeah. So Kyle built this where the spring is like a little bow because he's done a lot of bow carving.
Oh, okay.
Yeah, and he's like, "Oh, make a little bow to go in there to be the
Yeah.
spring," So there's that, and then of course there's the rock steps. I think you did a great job on that as well.
Beautiful.
But it's
Yeah, I
kind
love
of
the
like-
feeling of walking down in here.
We did try to avoid in our berm shed, which is 100 feet long.
Mm-hmm.
We tried to avoid the butt joints, and because if you get two butts over a post, it's like, okay, if you're gonna spike them both in, the amount of wood that's hanging on the spike is not very much, and then plus you're kind of a little close to the sides on the wood you're spiking into,
And it's
like-
still not very strong unless you have
So-
some sort of strapping over the top. I mean, any structure that we do that's engineered, there's going to be some sort of metal strap. Period. They hate those butt joints. In reality, because they've seen them fail. That's
Yeah.
where they've made so many insurance claims.
Yeah.
That they're
So-
like, even in our traditional joinery, they're
So
like,
we're
no,
not-
you're strapping something.
Josiah, you did a great job.
You did a great job, Josiah. Looks amazing. This is quite the daunting project for somebody to start way to stick it through. That's very well done.